Okay, so Mrs. Garcia's third grade class is planting a flower garden and a vegetable garden, okay? So they want us to draw a picture of the whole flower garden and the whole vegetable garden based on the parts that are shown. So if we had our magic eye, okay, and they're saying what you're seeing right here is only 1/3 of the garden, okay? So if we had this is our garden, okay? And what they're saying is we've planted flowers in this whole part here, okay? Now it's like they took scissors and they cut this out. They cut this out and they removed it and they put it right here. And they're saying you're seeing 1/3 of the flower garden. So can you draw the 2/3 that are empty? Okay, we're just seeing this picture. They cut this picture out and put it right there. They want us to draw the empty part of the garden that's not planted. So if this is 1/3, okay, in a perfect world, we'd have a ruler and we would go, okay, that's exactly 1 inch. So this would be about 1 inch. Okay, that'd be about another 1/3, and then that would be about another 1/3. So that's what the whole flower garden looks like, and we are looking at 1/3 of that, okay? Same with here. Okay, we have a garden. This is a round, beautiful garden, okay? And it's cut into 4 parts. And we've planted flowers in this part and in this part. And we've cut this out. We've cut this out and we put it right there. And they want to say, can you finish it off? 2 out of the 4 sections are the vegetable garden. Can you draw the other 2/4 that are not shaded in? And it would be like that. Okay? What do the fractions 1/3 and 2/4 tell you about the number of equal parts of the whole? Okay? Our denominator, our denominator down, okay? Denominator is how many parts we have total. And then the numerator is how many parts are shaded. So here we have 4 parts total. Even though we could only see 2 of them, we knew there were 4 parts and we could see 2 of them, okay? This one, we knew that there were 3 parts total, even though we could only see 1 of them. Okay, so here, what do the fractions 1/3 and 2/4 tell you about the number of equal parts in the whole? Is our denominators. This one right here, 1/3, we know has 3 parts total. Okay, this one right here, 2/4, we know has 4 parts total. That might look something like this. Okay, this bottom number tells us how many parts total, regardless of shading. Okay. Okay. Now, this is tricky, okay, because you need a ruler to do it. But when you watch the video, they kind of did a good job on it on the video, the Pearson video that you watched, okay? So Anya and Novi are running in different races. The diagrams below show how much of their race each runner has completed. Draw a picture of the whole track, write a fraction to represent the whole. Okay, so again, we know this is 1/6, okay? There's 6 parts total, we're seeing 1, so there must be 5 more sections over here, okay? But without a ruler, it's gonna be a little hard. So they did it for us down here, okay? This is 1 part, so they drew the 2nd part, the 3rd part, the 4th part, the 5th part, and the 6th part, okay? Don't worry about this too much. It's really pretty impossible without a ruler, but at least understand that when you're looking at 1/6, that the denominator is telling you there are really 6 parts. She's only run 1 of them, okay? Now, if you look at Novi's, his 1/6 is longer, okay? So his whole track is going to be much longer because each part of it is going to be bigger. They each have 6 parts, but Anya's part is smaller than Novi's part, okay? So Anya's, when you put 6 of her smaller parts together, it's gonna be a shorter track than when you put 6 of Novi's parts together because his parts are bigger, okay? So why is Novi's track longer than Anna's track or Anya's track? Well, because each of Novi's parts are longer. Okay, so if each of his parts are longer, then when you put 6 of them together, they're going to be longer than 6 of Anya's parts. Okay, let's look up here under another example. Okay, the part of the race that Rob has completed is shown at the right. Okay, so here is how much Rob has completed. It's not complete because it tells us that there are 3 parts total and we are only seeing 2 of them. Okay, so in order to fully understand 2 of them, we need to divide this in half. This is 1/3 and this is 1/3, which is what they've done for you right there. This was Rob's part right here. This is Rob's part, okay? And you're gonna take it and divide it in half, okay? So that this is 1/3 and this is 1/3. So we know there's 3 parts total. How many parts do we have there? 2. So we need to draw a 3rd part on there. Okay, and that would be just what they did right here. This was the original part, 2/3, and then they added another part to make it 3/3. Okay, again, this is kind of a tricky lesson, and it's very difficult not being there together in the classroom where I can, touch your book and help you do it. So just go with it. It's the more important part was yesterday's lesson about being able to really understand a numerator and a denominator, and being able to take a whole and divide it into 4 parts and shade 2 of them and write a fraction for it. So this is just kind of like an extension and a challenge a little bit, but it really does not require mastery at this point in the game, okay? All right, if the distance that Anya ran was 1/5 of the length of the track, what fraction would you use to represent the whole track? Okay, we want to represent the whole. The whole means that her track went like this and she's run all the way around it, okay? It means the whole thing is filled in, okay? So if her track is this long, okay, she's completed it. If this is 0 and this is 1, she's completed it, she's done the whole thing, if it's to represent the whole track. So how many parts total do we have? 5 parts, right? Because that tells us that right there, okay? What fraction would we use to represent the whole? Well, she ran 1/5, but if she ran the complete thing, she would run all 5 sections, okay? So whenever you have the whole circle represented, your denominator tells you how many parts total, and then the numerator tells you how many parts you have. And if you've done all of them, then they have to be the same, okay? So that equals the 1 whole. Okay, what is true about the numerator and the denominator of each fraction that represents 1 whole? If it represents the whole thing like this, okay, if Rob had done all of these, we would have 3/3, okay, because there's 3 parts total and we've shaded in all 3 of them, okay? If over here on this, our numerator was 3 because there's 3 parts. If we had planted flowers in the whole garden, we would plant flowers in 3 out of the 3 sections. If I said I planted flowers in the whole garden, what fraction of the garden is planted flowers? There are 4 sections total, and I must have filled in flowers in all 4 sections. So the numerator and the denominator must be the same anytime the fraction represents the whole thing, okay? So they are the same, okay? Now, draw a picture and write a fraction to represent the whole, okay? So draw a picture and write a fraction to represent the whole. So this is the whole thing. There we go. This is, okay, this is telling us, this is a little tricky, okay? This is telling us that there are 8 parts total, and this is 2 of them. So we're going to divide that in 2, okay? There are 8 parts total, and we're going to divide this in 2. So we are looking at 2/8 of the whole, and they want us to draw the rest of it, okay? Again, kind of like this, okay? This is 2 out of 8 parts, which means I still have 6 parts that are missing, okay? If I have 8 parts total, Okay, I divided this so that it's in 2. I have 8 parts total. I don't have 8 parts total. I have 2 parts right here. So 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. And they have shaded 2. These are the 2. So what I want to do here is go 1, 2, 3, 4, and I can make another one right underneath here. 5, 6, 7, 8. Again, this is tricky. So we're just going to do our best on it, okay? Down at the bottom. Okay. Draw a picture and write a fraction to represent the whole. Okay. If there are 3 parts total, and these are 2 of them, then I am missing 1 more part. Okay? And these are like little triangles, so we can go like this. Okay? And if we had all 3 of them, our fraction would be 3/3. Okay? This is half. So we have 2 parts total, and we are looking at 1. So we want to extend this line the same amount. Okay? So if this is 1/2, and then this would be 2 halves. Okay? See if you can finish this. You know, that should help. Okay? See if you can finish that. That's 3/4. You need to draw 4/4. Finish it off and write 4/4. Okay, 2, 6. Now the tricky part here is that it would be much easier if this showed us that it was 1/6. Okay, and we were saying, oh, there's 6 parts total and this is 1. It's not, it's 2. So you need to draw it and make that 2, 6. So now this is 1, 2. You are still missing 4 more parts because 2 parts plus 4 parts is going to equal your total of 6 parts. Okay, so go ahead and I want you to try to work on that. We can see how we did as far as, you know what, I'm just going to go ahead and show you. Why don't you pause it and see if you, why don't you pause it, do 6, 7, and the back, and let me just go ahead and correct this now. And that way we don't have to do it tomorrow morning on the video, and we'll have more time in the Zoom. So pause it, and then I'm going to show you, okay? All right, so on this one, you needed to close it up, and then your denominator would be 4, and you had 4 parts, which is 4/4, okay? Here you have 2 6, okay? So we need a total of 4 more. Okay, which would be 6 6. Okay? Okay, Ronnie and Gina were shown half of the table. They each drew a picture of the whole table. Okay, so this is which drawing is correct, okay? Well, they're both correct because you can take this triangle right here and kind of turn it sideways, right? And then put another one there, and that's going to be correct. Or Gina took this one and it's sideways like this, and it could go sideways like that. So again, these are so tricky with not being in the classroom, but it just, if this is half, then the other half needs to be exactly that shape and put up against it, which is easiest just to stick kind of behind it like that, okay? You could do it that way too, but they're both correct, okay? All right, if the part shown in 8 is, if this part, oh goodness, I already drew on it. Okay, so if this is 1/4 of the table, what would the whole table look like? Okay, so now we need, this is 1 out of 4, so we need 4 of these, okay? So you could kind of make it go like, you're just drawing triangles, right? Like that, and then like that, and then like that. That's probably how the table, and this was our original 1/4, and now we have 2, 3, 4, okay? And now write a fraction to represent the whole. If you forgot to do that, Then do that right now. Write a fraction that represents the whole table. How many parts do you have total? 4. And of those 4, if it's the whole table you're talking about all 4 parts, which is 4 fourths. All right, Mike has 8 nickels and 4 dimes. How much money does he have? Okay, well, 8 nickels, 2, 3, 4, 5, 6, 7, 8. Those are each worth 5 cents. And dimes, 1, 2, 3, 4. Those are each worth 10 cents. Okay, so if you didn't know what nickels, how much nickels and dimes were, then pause it and calculate how much money that is, and then come back. So that's 40 cents, 50, 60, 70, 80. 80 cents. Okay. All right. Jenna and Jamal are making rugs. They have finished the parts shown. Draw pictures to show each whole rug. Whose rug will be longer when it is finished? Okay. So, okay. They want to know whose rug will be longer when finished. So we're going to say blank's rug will be longer. Remember how we would do that? We would take the question and write it as a sentence. So whose rug is going to be longer? If this is her 1/3 and this is Jamal's 1/3, okay, Jamal, we're going to add another 1/3 and another 1/3, but hers are much smaller. Good thing I'm not a rug maker. So who's going to be longer? It's going to be Jamal because his parts are bigger. So when you have 3 of these, it's going to be much longer than 3 of those, okay? Okay. This picture shows 2/3 of a granola bar. Okay, well then, if this is 2/3, then let's make that 2. Okay, we have 2 parts, and then we should have another part. It's about that long. It's about that long. You know, it would be much better if they actually put this over and lined them up for you. That would be much nicer. I'm going to use like the tip of my pen, okay? It goes to right there, okay? So that's one's probably it. That's way too long. That's way too short. And that is about the exact same size that it was initially, right? 2/3 went to there. Went right to there. So that's the same size. This is like 1/3 of the, that's 1/3. This would be way too long. And that one should be about the same. Okay, so it should be A. Okay, each part below is 1/2 of a different whole. Which is the part of the largest whole? So this is 1/2, this is 1/2, this is 1/2, and this is 1/2. So to make each one a whole, you would need to draw the same length that's here, okay? Now again, it's very hard without a ruler. Okay, but even without doing that, I could tell it was going to be this one because this was the longest piece. So we're basically going to double each one of those. And if that's the longest piece, then when you extend it out and draw 2 of those, that's going to be the longest, okay? All right, don't get discouraged. This was a hard lesson. We will, it actually gets a little bit easier from here, okay? All right, good job.